Greetings and welcome. This is my fourth time doing this video. I didn't like the previous 3 times, so I want to try my best to get it right this time. We're just doing word problems using linear equations. And remember that a linear equation looks like y equals mx plus b. It's essential we establish our variables x and y, and all we're doing is just writing the equation. We're not necessarily solving, just creating a model to describe the situation. So let's actually try to describe our situation as time goes. Alright, here in the school year ending in 1993, 2 million females participated in U.S. high school sports. By 2003, the number had increased to 2.86 million. Write a linear equation that models female sports participation. I don't even know what just happened. We're back. So in this, just understand the whole I know and I don't know thing. If we understand that, we'll be able to do much. First off, I know. What you know is what happened in 1993. 1993, 2 million participants, right? In other thing you know is in 2000 you had 2.86 million participants. That's what we know, right? You only know what happened in 93 and in 2003. That doesn't mean you know what happened in between, just in those 2 particular years, right? So when we go over to I don't know, it's the first thing you don't know. You just don't. The thing that varies in this case, right, is the number of participants. That's the first thing that varies. The next thing that varies, that we're not sure, is the number of years. That's the other thing that's actually changing here, right? Now, here's the thing. One depends on the other. So, here's the thing that I want you to keep in mind. X is the independent variable. Y is the dependent variable, always. So when you're talking about the number of years and number of participants, which one of these events do you think depends on the other is what you should be asking yourself. So and if you see it, well, if you see it the way I do, is that the number of years is independent. The number of participants, how many participants there are, actually depends on what year it is, right? So if that's the case, then how about this? We let X equal the number of years, and we let Y equal the number of participants. Now, what you will notice is that there's a lot of participants. There's a lot of participants in this case. 2 million, 2.86 million, right? So how about we kind of make our equation look a little bit better by just doing the number of participants in millions. That way, in this case right here, if you're talking about there's 2 million participants, then Y would just equal 2. Since it's already said that it's in millions, right? And instead of putting X equals 1993 or X equals 2003, that will work, but just to make life a little easier, let's make this the number of years after not 2003. Let's make this the number of years after 1993. Let me show you what actually happens when had we have not done that, then the 2 points we can form, the 2 points that we got from the data right there, 1993, this is what happened, our X being 93, and our y being 2 million, we'd end up with that point. And in 2003, 2.86 million, we'd end up with that point. Now those points are relatively large. You can use them if you want to, but it's not necessary. So instead, we can use the 2 points. If we said years after 1993, right, then the points that we come up with is, our first one is 93, 2 million, right? So that means that in 1993, that's 0 years after 93, and in millions, 2. The other point that we get, 2003, 10 years after 93, and 2.86 million, 2.86. So really, from the actual information, we were able to come up with 2 data points. And because of those data points, well, what can we do with data points? We can find out our rate of change, right? So if we're trying to find out our rate of change, well, would I say another word for rate of change is slope, right? So we can find that with just y2 minus y1 over x2 minus x1. And being that we have those 2 points, that's just 2.86 minus 2 over 10 minus 0. We handle that. What's that going to be? 0.86 over 10. If I'm dividing by 10, all I got to do is just jump my decimal point back. So this is just 0.086, right? So I got my rate of change, right? And now I can find out what my actual linear function is that models this, right? So remember, your linear function is y equals mx plus b. Let's actually see what this looks like from the actual data. And you have y equals mx plus b. What we do know is our rate of change, right? Our rate of change is y equals 0.086 x plus b. If I just want to use one of the points, the easy one to use is 0.2, isn't it? So if I want to use 0.2, that means that 2 equals 0.086 times 0 plus b. So what does b equal? 2. So your linear equation that models this, your linear model, is just y equals 0.086 x plus 2. Now, the equation, you have to understand what the equation even means. Your rate of change, I'm going to need my highlighter for this one. Your rate of change is this how much you're changing per year. This is the increase in number of participants per year, right? In millions, of course. In millions. This is your initial value. Now remember, in millions or whatever, your initial value was 2 in millions. And based off of whatever data points that you get, you can find out, depending on what year, how many participants there are. Right? Let's go to another one. Example 6. You have $30 to spend on downloading songs for your digital music player. Company A charges 79 cents per song. Company B charges 99 cents per song. Now, the equation that we're going to come up with is a little different in terms of it's going to be in standard form because you have 2 different variables and they don't depend on each other. So let's try standard form for this. Remember, that's what standard form looks like, right? So as long as we understand what our variables are going to be, we kind of can formulate what our equation is going to look like. So first off, here's what I know. I know my company A price for a song? Well, let's call it song price. I know both song prices, so let's write that down. I know the song price for both of them. Anything else? That looks like Sony price. So my song price, and I know $30 to spend. That's what I know. What I don't know is the number of songs. Right? So let me be a little bit more specific. What I do know is the song price for company A, right? And I also know, hold up, song price for company B. Now, the song price for company A was 79 cents. And for company B it was 99 cents. Right? What I don't know is the number of songs for A and the number of songs for B. So if I don't know what it is, that's when I call it something, right? Now, since the number of songs for A and the number of songs for B don't depend on each other, they're in a way kind of both independent, then it doesn't matter which one you pick what, as long as the corresponding price goes with and everything. So from there, we can formulate what our equation is going to look like. So say you're talking about your budget, right? How are we going to find out how much money you're going to spend? Well, we know we got to spend $30, and how we're going to find out how much money we're going to spend is price for song A. Try to say price times number of songs, right? And let me give a little bit of room, because to be honest with you, I'm doing this twice. Well, almost that same thing. So let me lower this, and I will say that the part that I just did was just for company A. Right? So how much money I spent on that one, on those songs, plus the same, well, not the same, but price times number of songs, and this time this is going to be for company B. So we're doing our budget equals price times number of songs for company A, add that with the price times number of songs for company B. That's pretty much how much money I spent on both. So I could now start filling out what my equation is going to look like. My equation now is going to look like, all right, for my budget, I know my budget was 30. My price for company A songs, 79 cents. Let me verify. Yep, 79 cents. Number of songs for company A, I let that equal X. Plus price for company B songs was 99 cents. Number of songs, Y. So really from here, the equation I come up with is 0.79x plus 0.99y equals 30. Not really here to solve anything, just come up with the actual model. So this is pretty much two examples of the actual equations. We'll do more of the, I don't expect you to fully understand, but I want you to try your best on the homework, and we will cover that in class. So told you it wasn't gonna be that long. I'm gone.